So our force field is that guy. It's using that annoying IJ notation, but that's it. And the guy that we've got is a circle. Let's assume that we're going round it anti-clockwise. So can you imagine in this force field or weather system, if you want to think of it as like wind being blown, you start at this point and you go all the way around and you finish at that point. And we want to find what the work done would be. So we know that the work done is a line integral made up from the dot product of the force function with essentially dr. So what I have is my force function, right, my vector field, and it's only a 2-dimension. So it's x squared and xy. And I have a circle. But to get the work done, I need to find the line integral of f dr, which means I have to take this guy, this circle, and rewrite it in its parametric form, right, in terms of t. Right, so let's do that as a side issue. If you take a circle like that, would you agree its radius is 6? And wouldn't x equal r cos theta and y equal r sine theta would be a natural starting point? The radius is 6, so that's going to be x is 6. And instead of calling it theta, I'll just call it t to be consistent with all the others. And this is going to be 6 sine t. So there we go. There's our space curve in 2 dimensions. 6 cosine t, 6 sine t. That's basically x of t, and this is basically y of t. So we should be able to put this package together, and you're going to find a quite interesting answer. It's going to be the integral. Where does t equals when it starts, and what's the value of t when it finishes for a circle? I need a limit integration for t here. If you want to do a complete
0
circle,
to 2 pi?
Yeah. So you're just going to do a 0 to 2 pi. F is going to be x squared xy, right? And this guy here, right? This guy here is basically the derivative of this fella with respect to t, which is what, -6 sine t, comma the derivative of this with respect to t, which is 6 cosine t, dt. So that chunk there is basically what dr is equal to, and this chunk here is what f is equal to. So it's going to be from 0 to 2 pi. X squared is going to become 6, no, it isn't, 36 cos squared. XY is going to be that times that, so that's going to be 36 sine t cosine t. So that's that guy turned into t's, times this guy, dt. X times x plus y times y, what do we get? We got 0 to 2 pi. 36 times 6 is too hard to risk in my head. It's 216. So when you multiply this guy and this guy, you get negative 216 cos squared t times sine t. Add this guy times this guy, gets you 216 sine t cos squared t dt. And I don't actually need to do any work on this because I know what the answer is. What's the answer to that integral going to be? Don't overthink it.
0.
Yeah, because isn't that 0 and the integral of 0 is 0? And we would call this a conservative field. Conservation field. Okay.
It makes sense if you look at it because you're going against the grain as much as you're going with the grain. That makes sense.
Isn't it very balanced? Yes. Not sure which one of those pictures it is, but it shouldn't be too hard to just do the force field, right? That guy. Find out what the pattern of the arrows are, and I'm sure it is. I'm not sure why they would use that perpendicular, but evidently that is it. Any given point is perpendicular to it. Okay, and there's the solutions. Right, so yeah, they go in and they do that. Second question is a pain in the butt. I've tried it twice because I want to be prepared, and neither time did I get it right, although I know I'm doing the right method. So third time lucky. We're being asked to find this line integral. It's one of these line integrals written in their differential form, right? We saw that earlier on and then we disappeared, right? So this is a line integral dx, this is a line integral, right? The whole thing is a dx, a dy in it. And C is described, well, maybe that's where I made my mistake. It's described as going from the origin to this point here with coordinates 7, 1, and then going down here to this point with coordinates 8, 0. And so that's C. And this particular one is a little bit different than any of the others, because normally don't we just get one line, 2 or 3 dimensions? Here we've got 2 distinctly different lines. So first thing I'm going to do is find the integral of this thing, right? I won't write it all down. And I'm going to split it into 2 pieces. And the guy called C1 is going to be this, and the guy C2 is going to be this. So you can find the entire integral by finding this bit and then adding that bit. Does the logic of that seem reasonable? Right. You want to find the line integral, but the line is made up of 2 pieces. Well, find the line integral for the 2 pieces and add them. That's essentially what we're going to do. So let's look at this first one, the line C1. Well, it's a straight line from the origin to there, so it's pretty easy to do as Cartesians. But I don't want Cartesians. I need some parametric. Well, there is the easiest way in the world to create a parametric. Would you agree x equals t and y equals 7t does that job? Now let's look at C2 then. C2 is this line. It goes from that point to that point. And if I do a little rise over run, what's that going to be? That's 7.
Y equals x, it looks like.
Say again, it's y equals x or negative x?
Oh, it'd be negative, that's a negative slope, isn't it?
Right, so negative x, and I believe it's negative x add 8, but you can check it later, right? And in parametric form, it's going to be x equals t again, and then y is negative t add 8. So are you comfortable that you can turn straight lines into parametric by first finding what the equation is in terms of x's and y's, and then make x t and y is whatever, you know, this is. Make x equals t and y is whatever that is.
Wouldn't the 8 be the x-intercept, since that's when it crosses the...
Oh, let me check on that. When x is 8, what's the y? No, that's the right one.
Oh, okay. I thought about,
yeah, I mean, if I continued, it'd probably be up here and it would be 8. Yeah. All I'm doing here is I plugged in x is 8 and I want the thing to be 0. So yeah, negative 8 add 8 makes it 0. So I'm pretty comfortable with that. So let's find each one totally separately. The first one, C1, is going to be x add 7y dx plus x squared dy. And that's going to be the integral from t equals 0 to t equals 1. X is going to be replaced by a t. Y is going to be replaced by a 7t. And dx, oh, in this question here, won't dx eventually be dt, right? Dx by dt is 1 in the little cross multiply. So dx is just going to get replaced by dt. X squared becomes t squared. What does dy look like based on this information? What would dy be? Dx ends up being 1 times dt, but what will dy be?
7 dt.
Yeah. So we're going to get an extra 7 dt. Are you comfortable with that? Right. So let's make it look a little bit prettier. That's t plus 49t plus 7t squared dt. Guess I'm making a meal of it as usual. How about 50t plus 7t squared dt? So far, so good. If you integrate this, you're going to get 25t squared plus 77/3 t cubed, evaluated from t equals 0 to t equals 1. So it ends up being 25 plus 7/3, which I'm not going to even attempt. 25 plus 7/3. Now make it a fraction. 82/3. So that's us just found the C1 piece, right? So we found that answer. It's 82/3.
I was like, I ended up, again, it's just to verify that our equations were right.
Oh, check it for me, because you know this is my third version of this.
So I agree with the
Oh,
negative t plus a. It's the 7t. It should be 1/7.
this should be 1/7. Oh, 7 by 1. You found it. That's why I keep making a mistake. Oh, okay. Fixing it. This is going to be fun. Fixing it. That's going to be 1/7, which means that's going to be t, which makes that 2t, which makes that t squared. Okay. What's going to happen to the dt here is it's going to become a 7th. So it's going to be 1/7. That's going to be 1/7. That's going to be 1/7. And if you take 1 plus 1/7, you get 8/7. How does that look?
The one I'm looking at, it's saying that the answer is 20. I think you forgot the plus the other bit. C2.
Oh, I haven't started C2 yet, so I'm okay with that one. I haven't started this guy yet, but
Okay.
I will be doing him shortly.
That one it's saying is just negative 8 plus or 8 minus t.
This one,
Yeah.
which is the
Well,
same
now
as
we're good if
negative
we
t
get
and a.
20.
Right, so I won't
Yeah,
need to change that one
together.
after all. Right, this one I can keep. And we'll move on to the second piece then. And that's C2. And C2, double check it. It is negative x. Let's check that. That's 1. So it goes down 1 along 1, yeah. So it is y equals negative x add 8. And that is x equals t and y equals negative t plus 8. So the integral of this one then is going to be from t equals 0 to t equals 1. Is that going to be 1? Yeah. And we're going to get x add 7y dx plus x squared dy. Let me change these two around in a minute, but I'll keep them as 0 and 1 right now. X is equal to, put it that way, distracting. X is equal to t. y is equal to negative t add 8. dx is just t here. So that's that bit done. X squared is this guy squared, and dy is just negative dt. How does that look? Let's pause for a minute. X, that guy, 7y, 7 of that guy. Dx is dt, that guy. Plus x squared. Plus x squared. There we go. Negative dt. So I have the integral from 0 to 1, t, take away 7t, add 56, and that basically gets you that fella. And what do I have? Negative t squared, negative 6t, plus 56. Okay. Any mistakes here? Are we good as far as you can tell?
I don't see anything.
Okay, we will keep going. I'm still a bit unsure about the 0, 1, but I'll come to that in a minute. Negative 1/3 t cubed, take away 3t squared, plus 56t, evaluated at 0 and evaluated at 1. And if you plug in 1, you get negative that guy, plus 56, take away nothing. And that's something I don't want to do in my head either. So negative 1/3, take away 3, add 56, and then make it a fraction. And 158 thirds, that's just big. Not saying it's wrong, but it feels wrong. Anything that you can see in that part of the world? Any calculation that looks out?
Based off of the solutions I'm looking at, the limits are wrong.
Oh,
For both
so it's
C1
0 to
and
1.
C2. The limits of integration for both of them are wrong.
Right, so what should this be?
So for C2, it should be 7 to 8.
Okay.
So 7 being the lower limit, 8 being the upper limit.
Right. Which is kind of obvious if I bring my picture back.
Yeah, and then
The X
C1
starts
should
at
be
7
0
and
to
it
7.
finishes at 8. Yeah. Okay. So getting into this guy, if you plug in those numbers, do you have a number for me? So it's 7 to 8, not 0 to 1. The reason I was doing 0 to 1 is for 3D lines it is 0 to 1. But in this case, what you got? Well, I'm putting in the calculation, but it's going to take us forever. If you do everything correctly, and it's your homework question, you will get 20. So that'll be your correct answer at the end. It will be 20. And I'm not going to foot about with all these numbers anymore. It's frustrating me that I can't count, and it doesn't help you to see mistakes. So we'll call that 20 and let you figure it out. The method is correct, splitting it up is correct, I just can't count. So we got the last one to tackle, and that's us finished with these guys. We want this fella. We want to do x squared y cubed, take away the square root of x, and it's only with a dy. And that's still a line integral because of that little c. You might think, well, where's the so many stuff dx's? Well, technically there's a 0 dx there, but you don't write them down. And we are being asked to do c, and it's the curve, that guy, and it's going from the point 4,2 to the point 9,3. So I'm going to draw a little picture of them. Here is the square root function. Would go like that. It's going to be at the point 4,2. and it finishes up here at the point 9.3. Well, since I know that guy, x equals t, y equals the square root of t. It's going to be the parametric form. The integral is going to go from t equals 4 to t equals 9. So I got that right this time. Each of these guys is going to be turned into t's, including that guy. Well, since y is the square root of t, it's probably a good idea to call it t to the half. So when you do the derivative with respect to t, you get 1/2 t to the negative a half time, right? And then when you separate it, you get something like that. And then when you do the crossover, you get that guy. Does it look good so far? Right. So since I've kind of used up my room, the original one is now going to be from t equals 4 to 9. X squared becomes t squared. Y cubed becomes the square root of t cubed. Take away the square root of t becomes the square root of that guy. The dy becomes 1/2 square root of t dt. Let's pause on that one. X squared, good. Y cubed, good. Take away square root of x, good. 1/2 root t, yep, dt. So I've replaced all the pieces. It should be the integral from 4 to 9. That guy is t squared. That guy is t to the 3/2. That guy is t to the half. This guy is going to be 1/2 t to the negative a half dt. And the reason I'm doing that is I just want to combine these into fractional powers to make integration a little bit nicer. When you add these two together, you get 7/2. If you distribute through with this guy, and while we're at it, we'll just stick the half outside. This guy times this guy gets me t cubed, and this guy times this guy actually gets me 1. And there is an amazing thing. It's actually a nice answer. Pause again. Does that look good? Okay. Per rule, evaluate at t equals 4 to t equals 9. Okay, this answer better be 6285/8. Let's find out if it is. If you do 1/4 times 9 to the 4, so there's 1 divided by 4, which is that guy, times 9 to the power of 4, which is that guy. If you take away 9, you get that guy. And then if you make it a fraction, you get 6525/4. This guy's a whole number because that's 4 cubed, so that's 64. Take away 4 is 60, so you're just going to take away 60. And I got this answer. Subtract
Shouldn't there
60.
be a 1/2 in front of the 1/4 times 4 to the 4th minus 4?
What, this stuff here? Yeah,
The second part of it. You
is it a
got
half?
1/2 times 1/4 times 9 to the 4th minus 1 minus 1/4 times 4 to the 4th minus 4. You're not, you don't have the 1/2 on the negative there, the minus, you don't have the
Oh.
1/4 on the 1/2 on the t equals 4 section.
Does it help if I put another bracket around it now that it's got it?
Yep, that helps.
Okay. So we can take that guy, take away 60, make it a fraction. And that is 6285 quarters multiplied by a half, which is 6285 divided by 8. I knew I'd get one question right. It's 6285 eighths, which is the correct answer. Or at least it's the correct answer for the numbers I've got.
Good job.
I deserve a good job. 183 is not bad for me. I mean, I'd like 283, but you know, I'll settle for what little victories I can get. So our next section, it's got a pretty impressive name. It's chapter 16.3. And it's called Fundamental Theorem of Line Integrals. That's a pretty impressive name. Anything that's called the fundamental theorem doesn't that kind of mean it's big, it's important. Where was the other term? Can you remember back in Calc 2, the fundamental theorem of integration part 1 and the fundamental theorem of integration part 2? Remember those guys? Fundamental theorem of integration part 1 said that if you wanted to find the integral of a function, right, this guy, you could find the antiderivative at b and you take away the antiderivative at a. That's called the fundamental theorem of calculus part 2. Part 1 wasn't as interesting. Part 2 was. So we are going to be looking at the fundamental theorem ourselves. Now, let's see if we can start with, you're going to have, is it 2? Yeah, we'll do a 2. Nice, easy. Here is a 2 guy, and this fella is going to be called x squared plus y. And this guy is going to be x take away y squared, right? Just 2 random functions using x's and y's. We are going to call this guy p all the time, and this guy's q. So whenever I say p, I mean all of this, and whenever I say q, I mean all of this. So p and q are not constants. Aren't p and q just functions of x and y? It's just a convenience, right? So far, so good. We are going to look for a test for what's called a conservative field. So this is kind of the warm-up, the start to this problem. And it says the following. Any force field, any vector field, so another name for it, that has the property that the partial derivative of p with respect to y is the same thing as the partial derivative of q with respect to x is called a conservative field. And so the fundamental theorem, right, of line integrals only works for conservative fields, right? It only works for fields that have this property. And so you should test that it's actually a conservative field before we go and apply what you don't know yet is called the fundamental theorem, right? We're going to look at how that can be done. So let's take the one I've just done here, right? If you find the partial derivative with respect to y, right, of this guy, you get 1. If you find the partial derivative of this guy with respect to x, you also get 1. Agreed? So this one is a conservative field, right? They don't need to equal 1. They just need to equal the same thing, right? They can equal x plus y if you like, but as long as they're equal. So let me try another vector field, and I'll try my darndest to make it so that it isn't conservative. There. Now this is P, and that is Q. So the partial derivative of P with respect to y is the cosine of y, and the partial derivative of Q with respect to x is 1. This is not a conservative field, and therefore we shouldn't use the fundamental theorem of line integrals on it. So I can't think of a good analogy, but here's an analogy. Do you know if you're going to integrate something, shouldn't the thing be smooth, a nice curve? You would never try an integral, do an integral if the function was like piecewise or not continuous or something. Agreed? There are rules about when you can integrate things. We typically don't dwell on them because don't we assume that if you ask me to integrate it, it was okay to do it, right? And so we're probably going to be finding that that same kind of assumption is going to happen. We're going to assume that it's okay to use the fundamental theorem because it's a conservative field, even if we don't test it, right? So far, so good. Get that little guy out of the way. Questions that do that? Here is a version of the fundamental theorem. If a field is, right, if we field is a conservative field, then the line integral from P to Q, if you use it with C1 or you use root C2, or if you use root C3, you get the same answer. So if you have a conservative field, the fundamental theorem of integration says that it doesn't matter how you get from P to Q, right? You could do a straight line. You could do it as half a circle. You could do it as some random squiggle. The line integral, right, part of the force field going through that curve is the same answer in each of the 3 cases. Now, since that's true, wouldn't you always pick a straight line from P to Q? Because wouldn't that probably be the easiest, bearing in mind I can't count, but wouldn't that typically be the easiest way to get from P to Q?
Unless it's polar.
So again?
If you had a polar function and you were trying to go around a circle, it might not be the easiest to use a straight line. But
Right.
otherwise,
In fact,
yeah.
yeah. Well, yeah, but if you went from one side to the other, actually a circle's a special case. So let's do a circle. If you're a conservative field and you do a circular pathway, in other words, your start and finish point are the same point, right? You start there and then you finish there. That answer will be 0 every single time. In fact, if you start at any point and finish at any point, so in other words, your curve is actually a closed loop, won't the line integral be 0 if it's a conservative field? Does the logic of that make sense? That if you start and finish at the same number and it's a conservative field, circles included, the answer is 0. Conservative fields are really good. They behave well, right? A conservative field is like being continuous, right? It's a good thing to be if you want to do anything in calculus. Conservative thing is a good thing to be. What you don't want is a not a conservative field, because if it's not a conservative field, these three guys will be different. We're most likely to be different. In fact, starting at the same point and finishing at the same point might not be 0 if it's not a conservative field. And adding to the fundamental theorem, if you find a line integral of your function dot dr, in other words, the dot product version of it, it's described as f of, let's get this guy right down correctly, f of r of b take away f of r of a. What the heck, I'll write that again. It's very messy. That's a bit like saying the value of the function at b take away the value of the function a, right? Now, who is little f? Little f is like the antiderivative of big F. It's a bit strange notation, but it is. Pause on this for a minute.
Is that an F or a P? Like a capital
It's
F
an
or
F. It's an F. Like that. Suppose I give you a vector function x plus y. Now I need a conservative field to do it on, so let me start again. We found a conservative field earlier today, didn't we? Let me try and use that one. Does anybody get a copy of the early question that was already a conservative field? Okay, I can find one. Here is a conservative field. It's x squared y cubed, comma, x cubed y squared, right? Okay. Now, we assume that f is delta f. Remember that guy? And that means that f can be thought of as that guy. And our job is to find little f. Right? So in my thing here, I don't like that notation. I basically start and finish is how I would think of that, right? We're going to find who little f is. So if this guy is x squared y cubed, and this guy is x cubed y squared, and we know it's equal to this, we want to find who little f is, right? Who little baby f is. So what do I know? I know that the partial derivative with respect to x is this guy. Okay, now we're going to have to turn our heads upside down here. If you think of this as a derivative, how would you find f? What process would you use to find f if the derivative was this guy? How would you undo a
Integration.
derivative? Integration. So we are going to integrate this function, but partial integration. I haven't seen that before. Now, remember in partial differentiation, one of them is a variable and the other's a constant. Partial integration, same thing. Partial integration with respect to x. So you will get 1/3 x cubed, y cubed. Are you happy with what I just did there? With respect to x, the y cube's just a constant, right? Now, normally you would say plus c. Agreed? In this world, isn't c a constant, right? But isn't y a constant? So instead of saying plus c, you do plus g of y. Now, if I put a little box around that and say, I'll remember you, let's go and look at the second one. The partial derivative with respect to y is x cubed y squared, right? And that's now x cubed y squared. So far, so good. How do I find y this time? Or how do I find f this time? I almost told you what to do. I know the derivative with respect to y, the partial derivative is this. How would I find f?
Partial integration.
Right? And I get 1/3 x cubed y cubed plus a constant, which is some unknown function of x. And that's my second guy. And then what I do is I look at this guy and I look at this guy and I say, what conclusion can I make? Well, this guy and this guy are the same. In fact, that's the answer. Well, you might say, well, couldn't you have a plus x squared here or a minus y squared? These functions have to equal each other. Would you agree the only way they're going to equal each other is if these two things are 0? If you make this x, won't that not work? And if you make this y, that one won't work, right? You're going to have a letter of each variable left over. So those guys go away. And that's actually the most likely thing to happen. But occasionally you might have to tweak it, especially when it's 3 variables. So I now know this fella. And so if I tell you that my force field is this guy, are you now comfortable that you now know how to find his little f? Okay, that's my force field. This is my little f. So let's put the whole package together then. Let's suppose I had my vector field. And it starts at the point 1, 0, and it finishes at the point 7, 1, right? Just for argument's sake. So it starts here and it finishes up here. And I want to know the line integral from this point to that point. And the fundamental theorem of line integral says it doesn't actually matter what route you take. The answer is going to be f at the start, take away f at the end. I prefer that more than the generic formula that I wrote down here. It's a bit like f of b take away f of a. So let's see. The coordinates at the start were 1, 0. So this is going to be 1 of 1, 0. And the coordinates at the end were 7, 1. So all I really need to do is evaluate the function at its potentials. These are potentials. The potential at the beginning, the potential at the end. Right? And of course, got to get this the right way around. It should be the end take away the start. So 7, 1 take away 1, 1. It's always n take away start, right? B take away a. So pretend that bit's not there. Right. I got my function. It's this fella. It's going to be 1/3 times 7 cubed times 1 cubed. Take away, well, at 1, 0, what's that going to get me? 1/3 times 1 cubed times 0 cubed, which is just 0. And that guy gets me 7 cubed divided by 3. And the answer is some ridiculous fraction, 343 thirds. Once you know the potential function, right, this guy, that's his name. In this case, it's 1/3 x cubed y cubed. Can I find any line integral in this force field? Because don't I just evaluate the function at the end, take away the value of the potential function at the start? It's like capital F of B, take away capital F of A, right? It's like that guy. And as long as it's a conservative field, doesn't that mean you could go back to all those early homework questions, especially the ones I was screwing up? And couldn't you just hope, check it first, that it's a conservative field, find the potential function, and then just evaluate it at the start and finish coordinates, and don't care if it got there as a circle, or 2 lines, or half of a square root, or any other function, because it only depends on what the value of the potential function is at the end coordinate, take away the value of the potential function at its start coordinate. That is pretty cool stuff. Okay, last name, bye-bye. I'll hang about for a few moments and I'll see you tomorrow.
Thank
Have a
you.
great day.
You are going to find out that the last homework that we did is going to be 10 times easier now that you know the fundamental theorem, but only for the ones that are conservative. So that's why we needed the other method. Rosie, what you got for me?
Can you quickly go over finding parametric equations from linear equations again?
Parametric from linear. Are we talking 2D or 3D?
2D.
2D. Okay, suppose I was wanting to find the equation from the point 17 to the point 39, just for argument's sake, right? Then I would first have to find the equation of that line. So the slope is the rise over the run. The slope is 1. Try to make my life easy. And the equation of that line could be found by doing this guy. So that would be y take away 7 is 1, x take away 1. There we go, 7, 1. And this particular one ends up being x take away 1, add 6. So you find the equation of the line the way you would always find the equation of a line, right? 2x plus 3 minus x add 7, whatever it is. Now to make it parametric, you make x equals t and you make y t plus 6. There's your parametric. If your straight line was 1/7 x take away 8, your parametric would be make x equal t and make y equals 1/7 t take away 8. And you might say, well, why is that working? If I make x equals t, if you substitute t here, isn't y t plus 6? If I make x t, won't y be 1/7 t take away 8? Now, if the guy that you've got is a square root function, make x equals t, and y now becomes the square root of t. And that's how you turn a curve like y equals x squared and so on into parametric. Just make x equal t and y equal the formula. Now, what you got to be careful, which I wasn't, if you're doing a straight line from, you know, the point 1,3 to the point 7,9, make sure that t equals 1 and that t equals 7, right? Which is what I didn't do correct last time.